Uh-oh, folks, we got some visitors in the building. We got to put them on blast. Everybody, hey, take a look at your screen. We got some visitors in the house.
Mr. Isaacs.
Yeah. Hey.
Amigos.
Here today. What's going on?
Mr. Isaacs.
All right, only 14% of us got it right so far. I see some of us pick some answers, and 21% haven't answered at all. All right, well, 14% answered. All right, Kalani said C. It's more than one.
I really think it's everything but radiation.
Malik, the Matrix got you. Do me a favor. Try to mute yourself.
Cause you're lagging.
Yeah, you're lagging bad.
Who's that one person? Check.
Yeah, who's that one person? You want? All right, gotta put him on blast. Micaiah, we just waiting on you. One person. Get that answer in. So 87% is incorrect, with 7% is correct. So our solution should have been all the above. So we should have chosen every last one of them. So kind of you was there. You picked 3 of them, but it's actually all 4 of them. So let me just unshare the answer. And let's continue to move on.
But they're very far from 100% effective 100% of the time. So what would we have to do to find cures for all the different forms of cancer? We're beginning to understand a few of the problems scientists would have to solve. First of all, we need new, better ways of studying cancer. Most cancer treatments are developed using cell lines grown in labs from cultures of human tumors. These cultured cells have given us critical insights about cancer genetics and biology, but they lack much of the complexity of a tumor in an actual living organism. It's frequently the case that new drugs which work on these lab-grown cells will fail in clinical trials with real patients. One of the complexities of aggressive tumors is that they can have multiple populations of slightly different cancerous cells. Over time, distinct genetic mutations accumulate in cells in different parts of the tumor, giving rise to unique subclones. For example, aggressive brain tumors called glioblastomas can have as many as 6 different subclones in a single patient. This is called clonal heterogeneity, and it makes treatment difficult because a drug that works on one subclone may have no effect on another. Here's another challenge. A tumor is a dynamic, interconnected ecosystem where cancer cells constantly communicate with each other and with healthy cells nearby. They can induce normal cells to form blood vessels that feed the tumor and remove waste products. They can also interact with the immune system to actually suppress its function, keeping it from recognizing or destroying the cancer. If we could learn how to shut down these lines of communication, we'd have a better shot at vanquishing a tumor permanently.
Right, so why can cancer be so difficult to remove? So remember, they are mutated cells. So cells, they recreate their cells over and over, the same copies over and over. So when you have a mutated one, it starts to make mutated cells, but then actually these cells are actually all different, but they're all mutations. All right, because you can have more than one. And they also spread. Remember, they talked about how they can spread throughout the body. So you may have it in one organ, but it's already spread to another one, and you may not know. So they might have cleaned that actual organ out, not knowing that another organ was already affected. All right, right. So people don't actually go to the hospital when they actually think they have cancer. Like sometimes it's too late. and it's already spread, so it's difficult to remove. So that's why it's always good to get checked up or get checkups regularly and know your family history. So, like in my case, I'm looking at is cancer passed through genetics? Because if that's the case, then I have a higher chance now of actually getting cancer because my uncle's a cancer survivor, my dad's a cancer survivor, and they both had prostate cancer. So I have to get the prostate exam regularly, you know what I'm saying, just to make sure, you know, because it just happens in my family. All right, it comes from different effects. I don't know. And if you don't know, that's fine. Because, like I said, I mean, this is a lot of information to take in. They use a lot of big terms. I didn't hear nobody say anything about when they actually talked about the difference in how they respond to the same medication. So one may respond differently than the other. And beat it 2 times, we'll tell her congratulations. Because that's something to celebrate, to beat cancer twice. And also, people in our community need to start really looking into getting checked out more because, you know, a lot of the cancers that affect our communities are breast cancer and prostate cancer. And, you know, a lot of people don't get that checked until they get older. We should take more precaution and start getting checked early so we can have those early detections. So a lot of our people could be here longer. And, you know, the other occasional, you know, lung cancer that comes from smoking and, you know, the liver cancers come from drinking and stuff like that. So we need to be a little bit more aware of cancer in our community. All right, man. You gotta come and holler at me, man, Mr. Isaacs.
No doubt.
Well, you gotta wait a couple. You gotta wait a couple days. I gotta wait till my test come back. So you gotta wait a couple.
All right, bet. All right, y'all.
All right, man.
Class. I'll see y'all later.
Makai, what's the question mark for? Could you put something down here? I don't know what that language is. It's period LK